Good morning, on and all present here. I'm Nandini, DD. I'm working as an assistant professor in SNS College of Technology at the Department of Computer Science and Technology. Today, we are going to see a topic in data analytics on linear least square. So, first of all, we can see what is a linear least square. This linear least square is one of the mathematical method. It is used to find the best fitting straight line. So, in the straight line, which is the best fitting straight line, we are setting some data points. It minimizes the sum of square differences. That means the errors which has been observed, the values and the values predicted by the lines are being shown here. So we are going to find the line and which fits to that by making some errors, difference between actual and the predictive values, etc. These and all we are going to see. So first of all, we are going to see is what is the objective. So objective under this is understanding the concept of linear least square, formulate the linear regression models. We should apply the least square parameter estimations. So how we can analyze these errors and residuals. So how to evaluate the model fit and accuracy. So first one is a problem statement. In this problem statement, an actual value and a senior output has been defined here with the straight line with different plotted points. So how we can calibrate this real-time sensor data, how we are predicting it, how these values have been accurately find, how it fits to the linear least square model. Next one is to empathize this, we are going inside and one data, that is a man, or we can say is an IoT engineer. He needs to accurately find the temperature of an automatic manufactured line. So we are using some sensors here. First one is sensor drift over time to know the fluctuations. Second one is noise data due to environmental conditions. What are types of noise we are getting through wind, cloud, uh, nature, etc. So how it is delayed and what are the corrected actions have been taken here. So in this way we are empathizing it. So IoT engineer is thinking of it. Next one is what are the pain points we are facing here. That is first how we use this profile analysis. To that we have something like how this is stated, how it feels, how we think, how it can be done. So in the says, need to realize the reading fast. Next one, feels how frustrated that alarm gets failed. What he thinks is any data model is accurate or not. Next one is does this continuous monitors the dashboards. These and all we are going to see here. Next one is possible solutions. We have some four different possible solutions. First one is batch linear least square calibration. Next is recursive least square, weighted or regular least square, drift compensation, and future augmentation. And then first one, batch linear least square, how it is fit inside the sensor and how it collects the data. Next one, how it updates or calibrates with the parameter, what are the new data, how it gets arrived. Next one, how the weights are been applied, how this noise has been handled, we are going to see. Next is how this time, temperature, and how these drifts are being calculated. We are seeing these things. The first one is batch linear least square calibration. We are taking some sensors, some timers, some temperatures, and we are going to calculate it. So how we are adjusting the sensors, at the time of adjustment, how the temperature gets changed, before adjusting how the temperature is there, how the pressure gets changed, what are the voltages, how it has been recovered or changed, we are going to know. Next one is model parameter estimation. In this model parameter estimation, we are using two formulas. One is with linear model of x value and another with this y value. So y is equal to xb plus mu of y. So which gives x by beta plus epsilon is equal to x beta plus c. With this help of this formula, we can find the model parameter estimation. We are seeing in this diagram for x and y values, straight line with plotted lines, and y is equal to x of mu plus e. this value. Next is data correction. So how in this data correction, what are the difficulties or the error gets biased, how we remove the errors, and how the data has been measured. Next one is system identification. In the system identification, we should determine the system's behavior, what are the function, how it takes the inputs and returns the output. These are the things we are seeing here. Next is a overall mind map for this linear least square method. What are the squares? What are the application? How this mathematical bias has been treated? So what is an output we get from this? So these are the steps we have find here. Thank you so much.